Kyle.
I'm Taylor.
And Chris is not here today, but he will be back in the future. And we are going to be talking about data and moving data from one place to another. We're going to be getting into some ETL or extract, transform, and load discussions, using APIs, things like that.
Yeah.
But before we do, let's talk about a little piece of news that I saw last week, which was about a guy in Michigan that made his own ISP or internet service provider. We're using a lot of TLAs today, a lot of three-letter acronyms. And basically, let me share this screen here. But I want to make sure, since it's been a minute since I set this up, that we are actually broadcasting. Anybody out there watching, please let me know if we're not. It looks like we are live right now. Okay. So we're going to share screen, and we want to share this Chrome tab. And so this is on Tom's Hardware, but I saw it on, I think Engadget might have been the place where I first saw the story. But basically, there's this guy who wanted high-speed internet. He lived in a rural part of Michigan, and too slow. Comcast wanted something like $50,000 for laying fiber just to his house, go far away from their main line. So he decided to make his own. Got his neighbors involved, started charging people money, and then thanks to some COVID relief bills, the state got some funds, federal funds, for improving internet infrastructure, and he made an application and just got $2.6 million to expand it to another, several hundred homes. Oh, what do you think about that?
I think that's pretty cool. I think it would be nice if we could do that for all kind of public services, kind of like electricity down here in Texas.
Yeah,
you get a lot of options.
I think that one of the big differences is that people that internet's not classified as utility. Mm-hmm. There's a lot of people pushing to get internet classified as utility, but like electricity, gas, telephone, that's a utility.
Oh yeah,
but internet's not a utility.
Even though a telephone can carry the same, you can get internet over telephone.
That's how we used to,
and it's a utility.
My AOL disk.
So that's a utility. Yeah. But over any other medium, it's not.
Yeah, it's weird.
That's very strange. Yeah. Some legislative kind of malarkey.
It feels like either all of it should not be or all of it should be.
Yes.
But thanks to it not being, this guy was able to find a way around the system. I did some digging on creating your own ISP. It's not an easy task.
No.
There's a lot of places that will resell you internet that are basically already resellers that you can create your own, basically, internet billing company. So here in Texas, we have a deregulated energy billing, right? We don't actually have deregulated energy distribution. All the electricity in the Houston area come through CenterPoint, right?
Oh, yeah.
Just like the gas is. But you might be signed up with Zero or TXU or Reliant. And unless you're in an Entergy or Encore districts, then it's all actually coming from CenterPoint, regardless of who's billing it. Mm-hmm. There's a very similar situation I didn't realize with ISPs. Yeah. So anybody can go to one of these ISP third parties and set up an ISP company and start doing the billing for internet. And basically you can buy it at, I'm not going to say wholesale prices because they're actually piggybacking off of Verizon or Comcast or AT&T or Spectrum or somebody else already.
Or T-Mobile now.
Or T-Mobile now, yeah. So there's the core infrastructure that's been laid.
Yeah.
Then people are reselling that to somebody else who is now reselling it. But anyone can do that. That's not what this guy did. No. When you read here, he laid cable. He's out there doing it himself too. Like he's actually fishing lines.
He's just connecting to a data center. Or is he setting up data centers as well?
I don't know the details of that. I think he is connecting to major hubs that are there. Mm-hmm. Like he's laying his own line, but there are some major hubs that he is connected to.
Okay.
He's not running lines from, his house in Michigan to the Google office.
Oh yeah. No.
Right. Everybody at some point has to connect to these hubs.
Oh yeah.
So that's what he's doing. And he's charging anywhere from $55 a month to $79 a month for the unlimited 1 gigabyte speed.
That's pretty good.
Plus an installation fee, one-time fee of $200.
That's really good.
And then, or you could get the slow package at 100 megabits for $55.
I mean, 1 gigabit for $79 a month. That's unheard of.
Yeah, and I think he's just a guy who got fed up with big companies kind of abusing the power that they have. And I'm not going to say anything bad about Comcast in particular. It's just with big companies, as they get bigger, they tend to focus less on quality and more on price to retain customers. Because when people are considering a subject or considering a purchase, like what are the three main factors that people go after for
quality,
price. Right? Price, and then probably customer service
or availability.
Yeah. So maybe 4 there. And what studies have shown is that people are willing to put up with a lot of customer abuse if the price is right or the quality is right.
But it seems like nowadays both the quality and the price are both terrible. You're paying a lot of money for something that used to be good but is not great anymore.
And that's where you get into, is competition helping things or is it hurting things? Kind of crony capitalism, because pure competitive markets definitely should, in essence, be a race to the bottom on price.
Yeah.
But we're not seeing that. So there's something
like
else.
A race to the top.
Yeah, there's something else keeping those prices high. Yeah. So we won't spend any more time on it, but I thought this was a really interesting article. I thought it was really cool. Makes me want to go lay my own fiber lines. I just need $2.6 million.
That's it.
If anybody would like to help me start an ISP, please let me know. But really, what we're actually here for is man versus tech. And we want to talk about, we were thinking data conversion, right? That's a term that's been around for a long time.
Oh, yeah.
But really a better term is ETL project, extract, transform, load. When you think of ETL or data conversion, do you have any ideas come to mind?
I think of stuff like Alteryx. You're taking, Alteryx is kind of a data analytics software, but you're basically taking like a spreadsheet, or you're taking a CSV, I guess, some sort of data, and you're transforming it and getting insights from the data. So you could transform it into different types of data. So you can get, I guess the simplest type would be like mean, median, mode, but you could also get other types of statistics from it. That could be an ETL function. But something that also, like, there's different parts of ETL that come to mind, such as like data transfer and data transportation. That is a huge part of ETL that it's not really mentioned when you go and look on like Alteryx's website or anything, but it's a huge part in making not only those types of applications work, kind of classic ETL functions work, but also common applications you use every day that you might not think about might also use ETL kind of fringe functions.
Yeah, there's a lot to it. I've done a lot of heavy lifting just inside of Excel, right? And there are special ETL tools out there. And so when people think of data conversion, they're thinking of conversion, transformation, transportation, moving it from one geographic place to another, one server to another, all sorts of formatting, cleanup, data scrubbing, all these things. When really data conversion is more along the lines, if you were to say like just a data conversion is open the JPEG, save as PNG.
Yes.
That's a conversion.
Or going from like an XML to JSON.
Yes.
Similar structure, very, very different uses.
But even that requires some data manipulation. Like there has to be a conversion path to it.
Yes.
Right. And so you mentioned Alteryx. I'll go ahead and share 9 as well.
Wasn't Orange one of those? Orange?
Orange is a open source machine learning platform, and it does have some ETL functions to it. And so these are some data pipelining, citizen developer low code applications, and they can do really cool things, right? And there are some ETL specific applications out there. I'm just going to bring up a quick list from Tech Republic that I pulled up of ETL tools. And basically, these are tools just to help you with these. So AWS Glow, Azure Data Factory, Google Cloud Data Flow, InfoSphere Data Storage, Oracle Data Integrator, Informatica Power Center, Mapping Designer, Talend, Pentaho. So these are just some of them. They're pretty intense, though.
Oh, yeah.
They are pretty intense. And doing conversions is great to get from point A to point Z for people that are taking large sets of data.
Yes.
Right. One time though, like, do you want to constantly be doing data conversions?
Not usually. Like, I'd like to set the conversion and then automate it so that it just happens when this goes somewhere. It needs to go, and it's qualified with a certain parameter. Says like do this function, and it runs this ETL process, and then it goes where it needs to go. But I wouldn't want to do it manually every time now.
Yeah, I definitely wouldn't want to do it manually every time. And even automated, the more steps it has to go through, the more margin for error there is.
Yes.
The more opportunities for mistake to be made. You're taking two things that were not made to work together, and you're having to convert. You're having to change Coke into Pepsi. You're having to be an alchemist.
Yes.
Right. And there's just some inherent problems with that.
Yeah.
I've never done a data conversion project or any of these other. We'll use data conversion just as a simple term. Never done any of these projects where everything that was in data set A fit perfectly into data set B.
Well, that's why you're doing the conversion.
Right, yeah. Right. And even after converting, though, there's a lot of times cleanup that has to be done once it's in whatever system it's going into. Mm-hmm. So people have tried to address this. We've got tools, like I said, for doing data conversions. But also, this would not be great for, doing stuff rapidly or regularly live.
No.
What are some ways that people have to handle like live or data that's updated daily and has to move in between systems?
Well, you need kind of client end and program end functions to handle the data. Okay. But then, so I guess your ETL automated process on one end, and by ETL, I mean like you're doing the same kind of like cleanup every time. You're not doing like major transformations or conversions. It's just kind of assigning parameters to certain columns in databases or something like that. And then you'd set up an API, which we'll go into more detail, to connect to the client end application or front end. And that could also handle some conversion stuff. So it will take some data with a certain parameter and be like, okay, this goes here, but not necessarily a conversion the way we think about it in ETL.
Okay. Yeah, and so you brought up APIs. APIs are great. What is an API?
So it's an application programming interface.
Yeah, and I've got a Wikipedia article up here, so we can look at that. We could just make this podcast reading Wikipedia pages, but I think somebody else has already done that. Now, so you can see here APIs. The idea has been around for a while here, dating back to the 1940s and 50s. It says a lot of times when people go back that far, they're talking more about EDIs.
Yes.
And EDI is an electronic data interchange, right? And we'll
Which
touch
just
on
sounds
those.
old.
Yeah. I think I've got another Wikipedia article, actually, I could pull up about that. That is funny. Like you said, interchange just makes it sound like the World Wide Web,
Yes.
It just has the classic touch to it.
Yeah.
So EDIs were pretty standardized. They got pretty popular for batching data from one place to another over various transmission protocols to update data sets like on a daily basis.
Mm-hmm.
You know,
So kind of scheduled instead of
So at its core, EDIs and APIs are trying to do the same thing.
Yes.
Move data from point A to point B.
Mm-hmm.
They do it a little bit differently, though.
Yes.
And nowadays, APIs are used a lot more because they're more flexible,
Yes.
more robust. They can work synchronously or asynchronously.
Oh yeah. Even though the EDI, one of the EDI websites that we looked at in research for this episode, was very like they only work synchronously. It was very pro EDI.
So. Yes, it was. It was a very pro EDI website. I think that a lot of people may see API, and it's an application programming interface. Like that sounds intimidating.
Oh yeah.
Yeah. If you could break down an API into the simplest, friendliest terms, how would you describe an API?
It's just a standardized way, or it's a standardized to that application's way of kind of working with an application or a data set. But even if it's a data set, it's really communicated through that program side's application. So it's just an application's way of sending data and receiving data, kind of receiving instructions to do something with data you've sent with those instructions.
Yeah.
I will say that the documentation with a lot of APIs is quite a bit hard to kind of work with at first. Some are better than others, but you will come across APIs that just have very bad documentation.
Yeah. So every application that uses an API has a backend of some sort, whether it's moving files in and out or data in and out. And the API are kind of the rules.
Yes.
The descriptions of what this means to the application.
Yes.
So you can ask for, let's put it into some oil and gas terms just because it's easy. Let's say you're using an API for an oil and gas database. It defines like, hey, if you want the lease ID, you need to call the lease_ID column.
Yes.
If you want to get the owner name, you need to call the owner_ID column, and then these are the fields that come along with it.
Oh yeah.
That kind of thing. So it's just a set of rules, really,
it's
for
kind of
exposed data.
It's kind of similar to SQL, the language. So when you're putting it into a URL or you're kind of running that get statement or post statement, which are different statements that you can use to. So if you're doing like a get, you're basically requesting data. If you're doing a post, you're giving data. If you're updating, you're giving data, but you're only doing it to certain ones. So it's kind of like SQL, where you can specify what kind of data and columns and categories of data you want to do. You can do a lot of different things with it. So yeah.
Yeah, and so with an API, we've talked about how you can do live updates. You can push, you can pull, like you're talking about with get and post. You could do that. The documentation, like you were talking about, so that's up to every application. Everyone who defines an API has to write instructions for anybody to be able to use it. So that's wildly varying. What are some of the APIs that we use around here?
So we use an API to send documents to an IDP application that's web-based.
Are you talking about Alchemy?
Yes.
Yeah. So we're partners with Alchemy. They're an online and what's called intelligent document processing application. Really big in the financial sector. We're bringing a lot of those tools to oil and gas and other industries, healthcare as one of our focuses with it, and we do the financial stuff too. So if anybody, shout out to Alchemy, our partners out there, and if anybody needs any help with Alchemy, we're happy to help.
Oh yeah.
But yeah, we use their API for sending documents to them.
Yes. And they have a great documentation, by the way. But basically, we just, on our side, our application, we take the documents and we convert them to bits or bytes. And then we send those to them. They get it and kind of turn it back into a PDF or whatever kind document came in as. And then they run, their application on it, and they get data from that, and they send the data back to us. And the whole time we're also polling, so we're getting status information about the documents. Are they being OCR'd? Are they being extracted or classified? So we get that back, and then we get the data back, and it's into a database.
So you can use the same API
Yes.
for sending files, for checking on the status of a process or a project or a file, and then getting back tabular data.
Yes.
That's all one API. And when we set this up, like to set it up, what do you need to know to be able to work with an API?
You need to know how to to work with a specific AI or with just
with setting up the API. Like you said, we had to convert it to bytes. We have to send them data. We have to get data back from them. Like, are you programming something?
You are definitely programming something. There are certain APIs that the common way of testing an API, like if you made the API, you could test it on like Postman, or you can test it through your browser. But with someone else's API, it's a little difficult to do that sometimes. So for this one, I would see like what functions you want to do, what the API you want to target requires for that function, like the input or the output that you want to receive. And then just kind of pick a programming language. It can be any programming language you want, because they all have API functionality where you can communicate with the API. And then you just got to troubleshoot. It's a lot of trial and error until you get it right.
So if working with it is similar to SQL and you have to do programming anyways, why have an API instead of just like an FTP for sending files and a SQL Server database that has a internet accessible port on it? Like, what's the benefit of an API then?
Usually, I feel like the benefit of an API is it can work with applications of any kind. So, if you had just a FTP to send and receive documents, well, I can't send the documents and then also get back data from the same place. I would have to go, I got to send it through FTP. Then I got to go hook up to their SQL Server database through any means. But that's two different things. So now I'm only using one place to go, and it does it automatically.
So it simplifies it.
Yes.
It also adds a security layer in there too, right? Because they're getting data from their database. Just talking about databases, SQL Server, because I've used plenty of internet exposed SQL Server databases. And with an API, it adds a middle layer that insulates that database so that people aren't directly interacting with it. You can't do a SQL injection attack on an API.
No.
Because it is, as syntaxically or conceptually similar the syntax may be to a SQL request, it's not actually interacting with the database.
No.
It's a middle layer there. So APIs do add a
and
layer
you got
of security.
SSL certificates and stuff like that. If you do HTTPS.
Yeah. So you could
HTTPS.
So you could secure over that. And it does, and like you said, it uses just the HTTP and HTTPS protocols.
Yes.
So it's not specialized protocols that you're needing to use.
Not usually.
So just any internet connection should be able to work.
And usually, with most APIs, you get a you get a API authentication token, so you can insert the token, and that's how you use it.
Yeah. So they're secured that way. So there's some benefits to it. I just wanted to explain why you'd want that instead of just exposing things online. And then, so we talked about moving files, moving data.
Yes.
Getting status updates. I've used APIs for licensing, creating a licensing API.
Oh, yeah.
Anytime you get onto an application that has to check to see if you are using a licensed version, such as Microsoft Office, it's doing a check to see like, is this a licensed version? Windows does that. It's not as big a problem now, but back with Windows XP, everybody was sharing Windows codes, right? And they were sharing them online, and there were big problems with people buying computers that had been licensed with XP from a third party, and that Windows code had been used 10, 20 times.
Oh, yeah.
And Windows was checking to see, is this a valid code? And then they, without having to make updates to the computer, made updates to their API to also see like, well, how many times has this code checked in? from how many different computers, how many different IP addresses, so they can start tracking piracy a whole lot better.
Interesting.
So server side API, there's things that you can change to improve your API for getting information without detrimenting the downstream applications as much either.
It's easier to update the client, or the data the client is receiving by not modifying the API at all.
Yeah.
Yeah.
So you can, and as opposed to, you may have to change the structure of your database. You may have to expand a table, add multiple tables.
Basically scale your application.
You could do an entire conversion from Microsoft SQL Server to MySQL on the back end and use the same API as your middle layer, so that your clients didn't even know that you were doing a back end data conversion from one system to another, as long as you kept all your rules the same.
Oh yeah, I mean, you just change the connection settings in your application to just connect to a new database.
Yeah, or vice versa. Also, not encouraging anyone to switch away from SQL Server. You could switch to a Microsoft application for things.
Or let's say you wanted to switch to a new cloud hosting database system, such as like RDS. You could switch that. It would be the same sort of sequence. Yeah,
so you can switch that. And like you said, the API does more than just interact with the database, right? It interacts with applications.
Oh, yeah.
So if you were rewriting, your application into a different language, the API doesn't have to get affected as far as the client's concerned. The way that the server interacts with the API may change. But then because it sets up a wall, everything after that wall is the same. So that's pretty cool.
Yeah.
You ever made an API?
I have.
Yeah.
I think 2 of them, actually.
Yeah. So let's see. So when somebody's making an API, what might be a reason that they want to make an API?
They might have some sort of database system that they want to connect to an external application over the internet. And mainly, at least the reason I want to do that is so that if it's not connected to the internet, it just won't work. So it must be connected to the internet to work, mainly because it was a sort of licensing program, or it needed to check for licenses. And if it wasn't able to check for the license, it just wouldn't run. For security reasons.
There's a lot of mobile apps that do that.
Oh, yeah. And then another was basically just serving files to another API. But it also acted so that you could upload files to it as an API. And then it would upload to another API.
Okay.
So kind of an inception of APIs in a way.
API within an API.
Yes.
The AAPPII.
Which I believe there's a lot of applications that do that.
There are, because you might have an API. You might have one application that's pulling in data from other places that you don't control. You have to have their API. And then you want to provide a unified interface to your client, even if it's an internal client. That they only interact with one endpoint instead of the multiple endpoints.
Kind of like Alchemy. They've got their API, and then let's say they're OCRing, they'll contact whatever OCR API they use to check for licensing. And they might use another one for their extraction techniques. I'm not sure what they use, but something like that. They'll check an API for licensing.
Yeah, so there's benefit to it for just simplifying, making it as simple as possible for the people at the end, for creating not a unified system, but maybe an interoperable system, a system where people can communicate with each other.
Very modular.
Yes. Yeah. There you go. Very modular. So someone could have database A and database B, and for security purposes, you may not want to convert stuff directly from one database to another.
Oh, of course.
But you can, through an API, give people access to the content of one database, so the second database can pull that in.
Oh, yeah.
And push stuff out to give feedback back to the first database.
Exactly.
And that could be a very safe way to share information between accounting and land, or operations and management, that kind of thing.
Yeah.
Well, that sounds good.
Yeah. It's pretty cool.
Yeah. So we're coming up right on our 30-minute mark. I know this has gotten a little technical with it, but I think it's a good overview of some extract, transform, and load, kind of what goes into that. And then also maybe a modern alternative to needing to do that all the time is an API. And while that is a technical endeavor, it shouldn't be daunting. It actually makes life a whole lot easier to have it.
So man versus tech. I would say instead of man or tech winning in this one, I think it's man needs tech for this one. This is where tech really helps out.
I think so. So, if we were to frame it as the man versus tech, I would think like, okay, if you're doing a data conversion, let's say somebody sends you, 40 CSV files.
Okay.
And they need it inside of a SQL Server database.
Okay.
And now you have to take those CSVs and you have to convert it, and then you have to deliver a .SQL, and script that data into a database.
Okay.
Okay. That's going to be a huge undertaking.
Yes. Oh, yeah.
Versus, I think that's as manual as you can get that.
Oh, yeah.
Versus if the data, instead of being exported to CSV from database A, if they just had an API out there that database B could use to pull data into how they wanted. Because that's one thing with APIs is they're giving you the rules on how to pull stuff, not what to do with it once you pull it. So you get to put that where you want it.
Yes.
I think that's a way better way.
Oh, it is.
So 100%. I think the newer tech wins in that one.
Even the older, like at first, the older tech, I feel like really helped out instead of getting, I saw that it was meant for, like the EDIs were meant for like paper invoices, replacing that. It is a lot easier to get that information electronically than on paper.
It is. Maybe it's an outdated phrase, but standing on the shoulders of giants.
Yes.
Right. That's very much where technology is these days. Hopefully that didn't come across as complaining about EDIs at all. Like you said, they were huge leaps and bounds, but it's like, okay, databases were such a huge leap beyond paper ledgers.
Yeah. Oh, yes.
And then databases with GUIs were so much more than DOS and text-based access. And then relational databases above singular tables. And then batch updating with imports. And then EDIs to electronically transmit that over the internet instead of having to like email a file and import it every time. And now we're at the API level. And it's like generationally, or technologically, we're like 6 or 7 generations down the line.
Oh, yeah. I mean,
with this.
Went from smoke signals to this,
Yes. So we have come a long way. And what I'm learning with each of these episodes that we do, it's less about man versus tech and about how man uses tech to make life easier and better.
It's not like a competition. I mean, it can really feel like a competition sometimes, like making your own API and you're on the 5th page Google. And you're about to pull your hair out, it's man versus tech. But, when you get it right, then it's like man with tech.
Yes.
Or tech for man.
Yes.
Yeah.
Well, good stuff. Well, thank you, Taylor, for joining me.
Thank you.
This has been Man versus Tech. I'm Kyle Souza. Please tune in on Wednesdays from 11 to 11:30-ish. And we will see you on LinkedIn, YouTube, and whatnot. Have a good one.